Good afternoon. My name is Benjamin Rhodes. I'm a PhD student here at UNT Charlotte, and I was asked to fill in for Mark on Monday night as a guest lecturer for your Introduction to Engineering class, and through some miscommunication we missed each other. So I wanted to make a makeup lecture here on YouTube, and just to show you some of the basics of the Boe-Bot and some of the basic sensors and how we're going to be programming the robot the next couple weeks. So just to get you familiar with the robot, I am going to use some slides by Eddie Lindsay. He's from Parallax, and this is based upon the book that comes with your kit. And if you don't have a book, just ask Mark and he will be able to get you one. So going quickly through here, again I'm going to use this presentation more or less as a guide for my presentation. However, there will be some other items we're going to look at as well. So here is our Boe-Bot. It comes with the basic Stamp 2 microcontroller. This is our microcontroller we're going to be working with. And a couple things to note about that is this is what's called a dual inline package or DIP package. And there are also some controllers on here that are surface mount. If you can see here, this is a PIC microcontroller that we're actually going to be programming on the board. This particular Boe-Bot already has some of the sensors and LEDs and speaker on it, but we're going to be looking into that throughout this lecture as well. So one of the first things we have to do is to get the IDE or Integrated Development Environment downloaded to our PC so we can start programming the robot. And so if you go to this website here, this parallax.com/basic stamp software, and I'll put the links in the description. If you go to this website here on parallax.com, it'll have all the basic software that you need. So the one that you're going to need more than likely is the one for Windows, which is this one here, the basic stamp editor for Windows. You'll click on that. It'll download a file for you. Actually, it'll go to the next screen, I'm sorry. So you're going to want to choose the newest editor, which is this one here. It's an exe file. So that will download. I'm using Chrome as my browser right now, but if you use Edge or any other browser, you should be fine. It'll take it a few seconds to download. I've actually already downloaded the software, so you'll just have to go through the process of downloading the software. Another thing you will have to do is get the drivers for your particular robot, which is our Boe-Bot. So if I go to, I think it's over here, let's see, one of these. Yeah, okay, so if we go, the main download page, you're going to see the Parallax USB driver installer. So you're going to want to go ahead and download that first as well. Go ahead and download that. Again, it just makes a simple download. You're going to want to choose the EXE, which is the newest one here. If you have, for some reason, a problem with administrator privileges problems, you can choose the .zip file, and it'll also get there for you. You can extract that file later on. Again, I've already done both of those steps, but you do need to do both of those steps. Whenever you get done, what you'll end up with is, under Parallax folder, you will see this basic stamp editor, version 2.5.3. Now if you're in Windows 10, let me go to that start menu, should still be under all apps here, and it should be under Parallax. Let me go down and I'll find that as well. So there's Parallax, and there's my basic stamp editor. Okay, so it depends on what version of Windows you have. Okay, so let's go ahead and click on the basic stamp editor and kind of get familiar with the interface. See how it works. So it should come up similar to this. Alright, it's going to have us some basic items here. This tip of the day, you can X off of that whenever you get it, or you can uncheck this show tips on startup. That's up to you. I think they are kind of helpful. Now this is your basic window environment. So let's go back to the slides here for just a moment, and we can see what else we're going to look at here. As soon as this loads up, Takes it just a second. There we go. Alright, so we went ahead and went to the website and downloaded everything correctly. And again, this is your basic stamp. This is for an older version, but it's still the same. And we can go through some of these slides here. Now the first thing we're going to have to do is actually put our microcontroller onto our board. So if I switch over to here, which is my webcam, you're going to see one of the team's Boe-Bots that I have over here. Okay, so this is where we're going to be inserting the microcontroller. Now your microcontroller comes in a kit similar to this. See if I can get it to focus. Okay, I'm going to go ahead and take that out of the bag. Now it's going to be very important we put this into the board correctly. Alright, so it's going to come on this little box here. Go ahead and take it out of its holder here. Now let's go ahead and observe some things about this board. Now notice that it says BS2 on the top of it, revision K. Lay it there so it'll autofocus here. Another thing you're going to want to notice is a little notch up here at the very top. Okay, that is going to be our up motion over here. So it kind of gives you an idea of where the devices should go with the two or small devices here and a larger device here. So this is how we'll be inserting this into the Boe-Bot. Now it is important to be careful with these pins. They're pretty fragile. So let's go ahead and insert this controller into our robot. There we go. Alright, excellent. So this is what yours should look like whenever you get done. Alright, we can discard of this extra paperwork now. Now, how we're going to program the robot is, since we have the serial bot, which has the serial connector here on the end, we're going to have to use an adapter to go to USB. Okay, that adapter is located inside of your kit. It's called the USB to serial adapter. I'll go ahead and take that out. Also notice the warning, it says install software first, and it tells you the website to go to. We've already done that on our PCs at this point. If not, you can pause the video and go ahead and do that. Again, the website for that is parallax.com/USB drivers. Okay, that's what we're going to look for. So parallax.com/USB drivers. This is what's inside of the box. Okay, it is an adapter that goes from USB to serial. Okay, we're also going to be using the supplied USB cable that come with the kit. Alright, let's go ahead and unwrap the USB kit here real quickly. There we go. Now here's our USB and our serial adapter. I will go ahead and plug in those two together. Then you're going to want to mate that to the back of the board as so. Okay, this will go into the board here. Alright, now this will be plugged in to our PC. So I will go ahead and plug it into my PC. Let me get this a little bit better picture here. Alright, so I'm going to go ahead and plug it into my PC. On any one of your available USB ports will be fine. Alright. Now the first thing you should notice is a little green light right here should come on. Okay. On the USB to serial adapter. Also, you should see if it needs to install any drivers, it should automatically do so since we've already downloaded the drivers from the Parallax website. And there's a lot of help online for this as well. Okay, so if you're having problems, you can pause the video and go do some help forums online. It'll help you out really quickly. Alright, so we've got the Boe-Bot plugged in. And let's take a look at some of the options that we have here on the Boe-Bot. Okay, alright, so let me get my video back here. Again, we've already plugged in the USB to serial adapter into the board. Alright, so this is going to be our breadboard. We're going to talk a little more about that a little later in the video, about how we're going to use the breadboard. We also have what's called ports. See, this is P15 down to P0. Okay. we're actually going to be able to program those particular pins. Okay. Having a little problem with my webcam software, but I'll get back. Alright, so also notice how those pins correlate to the pins on the microcontroller. So we have P0 through P15 on the microcontroller, and that correlates to P0 to P15 onto the board. Now another thing to make note of is the cable connections over here. That this team that I've used their robot as an example today already have their servos wired in. However, on the breadboard there's this VDD, VN, and VSS. We'll get to those pins a little later in the video, but those are where you're going to basically get your power and your ground from. Okay. They also have a switch on the Boe-Bot that has 3 positions: position 0, position 1, and position 2. Okay. 1 essentially just turns on the robot, okay, enough to get power. Notice this green LED light will come on. I'll go ahead and turn it off again. You have to have batteries on at this point, so there, I turn it on, green light comes on, and the switch in position 2 actually will turn the robot on. You might have actually heard the servos kick on at that point. Okay. Alright, so we're going to go ahead and leave that there for a little while. Let's go ahead and get back to the presentation here. Again, we went ahead and connected everything correctly. Again, I will not be using all the stuff from this slide set, but I will post the link to this slide set in the description below. So here's some of the components. Luckily for y'all have already completely assembled the robot, so we don't need to go through this step. Again, position 1 is when the power is on. And this is our servos. Now we'll be getting that a little bit later in the video, but this does highlight some of the parts of the servo that we're going to be talking about a little later. Again, this team here already had the servos connected to the correct part. Alright, so let's get to what we're trying to do in the class. So a general overview is we're trying to make this Amazon fulfillment robot. Now let's go ahead and play this video here for just a moment. I'm going to turn the volume off here so it won't interrupt my recording. Let's take a look at these robots that Amazon currently has working in their facility. So these little robots here actually are able to traverse around, and they're going to be able to find their particular case or rack that they're going to try to transport around the particular plant. Okay, they're actually very strong. They can go up underneath the carriages and then move around autonomously. Okay. However, they don't do this alone. They're going to have some sensors in order to figure out where they are in the world. Okay, and we're going to be using some of those sensors on our Boe-Bot. Okay. Again, look here, they're working in tandem. They make sure they can avoid each other and avoid hitting other things. So it's a really smart system of moving inventory that Amazon is trying to work on. And that's what we're going to try to mimic with this project in this class. Alright, so again, I'll put the link to this video in the description as well. Alright, so we went ahead and downloaded all of our software to Windows or Linux or Mac, depending on which one you're using. They have capabilities of all of those. There also is one other option. If you have a Chromebook, there's this Parallax IDE plugin from the Chrome Web Store. And this actually is an IDE that you can do straight from Chrome. So if you have a Chromebook, don't fear. You can actually use this plugin for Chrome to download to the Boe-Bot. Alrighty. Now let's go ahead and pull back up our PBasic editor. Okay. There's a couple different options here I want you to look at. Up here on the top panel is some of your basic controls. There's your new file, open, save, print, cut, paste. Those are your basic things. Okay. Some of the things I'm going to be talking about today is some more options over here. Okay. Specifically choosing which one of these boards that we're using. Now luckily for us, there's a lot of example software for this Boe-Bot and example programs for the robot. Okay. So if you go under File, Open From, we're using the BS2. That's our particular microcontroller, the BS2. So if I open up the default BS2 directory, it's going to give me some examples to go by. Okay, there's some different statements here. There's some different structures. A lot of these are all examples that we can use later on. Okay. another thing that we can do is actually use the book that come with the, let's see if I can find it here. Where is this at? Pardon me here, I got to find the actual book. Well, I might as well show you how to Google it. So you just look up under Boe-Bot, look under Boe-Bot, Robotics version 3.0 is the book that we're trying to do. And here's the text for the robot here. These are the very first link. It's going to give us an option here for the text. And here it is, Robotics with Boe-Bot version 3.0. Now I suggest looking at the PDF version of this book, mainly just because you actually can copy and paste this code for yourself. Okay, so for example, if we wanted to go over, let's see if I can find a quick example. So let's say we're looking at this code here. I simply can copy and paste this code into my particular program. Okay, and we'll be doing that here in a moment as well. Okay, so again, if you've not got the software up and running, feel free just to pause the video and get that up and running. And again, you can look on the help forums online, or there's other YouTube videos showing you how to set up these particular robots. Okay, alright, great. So we're going to come back to here. And again, this is how you open up examples. You just went to File, Open from the BS2 directory. And again, there's some examples to kind of get you started. Let's take a look at one here just for an example. Let's look for frequency out. This is an example because we're going to be talking about frequency a lot in this video. It automatically opens up the program for you. Okay. Now there's a lot of things going on. Okay, so if you've never programmed before, we're going to be going over some of the very basics of how to program the robot. The main thing I want you to focus on right now are these first two lines. Okay, these will be in any program you're going to start. The Stamp Basic BS2 tells the computer what kind of controller you're working with, and the PBasic 2.5 tells what version of PBasic that you're using. Okay. Now, let's say, for instance, we started a brand new file, nothing was there. You can actually insert those two items just by clicking on the BS2 here, which is the second controller. It says OK. And then click in 2.5 here. It'll give you a message saying, hey, you've used the PBasic language 2.5. Okay. Now, another thing we have to notice inside this IDE or Integrated Development Environment is the different colors. Okay. So what we have here in green is what's called a comment. And I initiate a comment by having a apostrophe. Okay? So if I say this is a comment, okay, the computer is not going to read in this line because it is in green. It's just an information for us. Again, you can see here that this green up here just kind of gives an example of what the program is supposed to do. Okay? And again, it has those same two lines we talked about a minute ago. Now this is a pretty long example. We're going to be doing a little simpler example. Okay, just wanted to show you where that option was. So here is our original program. Usually it's always best to put comments in your code. Okay, it's a programming practice. So this program will introduce WCC Intro to Engineering students to the Boe-Bot IDE. Again, it just kind of gives a description. I also like to put the programmer in here. Okay, I'll go ahead and put my email in here if you want to contact me. Alright, so again, this is part of our code we're working with here. Now, before we can do any kind of code though, we have to figure out exactly what kind of peripherals we're working with. And peripherals, I mean sensors and things of that sort, motors, how we're going to get this thing to move. Okay, so let's go ahead and look back at our robot here. Start back my webcam viewer. Now, this is a very basic Boe-Bot. This is one of the teams that I've used for the Boe-Bots. Let me let it focus here. There we go. and there's nothing on it. The only thing we have right now is the servos. Okay, so I think that'd be probably a pretty good place to start. So one of your peripherals to your board, and a peripheral just means anything that is not contained on your particular board. So anything that's not in this green area is a peripheral or external to this board. So one of the first peripherals you have on this robot is the servo motors. And we actually have some unique servo motors. They're called continuous rotation servo motors. And we're going to take a look at exactly how those work. Okay. So again, hopefully you've got the connections similar to this. This is the guideline from the book directly, how you hook your servo motors in. They have 3 wires. They have a red wire, which is your voltage in, a black wire, which is your ground, and a white wire, which is your signal, that are hooked into P13 and P12. Again, P12 and P13 are the same as over here. So here's P13 and here's P12. Okay? And we see that over here as well at the top of the Boe-Bot, right off screen. Okay? Alright, so for us, we're going to try to program these particular servos. But again, what is a servo? Okay? Again, we have a continuous rotation servo, and based upon the pulse width here, we actually can make the robot go forwards or backwards. Okay? So let's look at some of these signals here and kind of determine what this signal is. So this is a square wave, because it looks like a square. Okay? And then we have one particular cycle. So if you see here, this is a 20 millisecond period, they call it, for each one of these examples. So each period lasts 20 seconds. Okay? Now this spike going up represents a spike in voltage. So this would be a 5-volt potential level, and this would be 0 volts. Okay? So for 0.5 milliseconds, the voltage will go high and then back off for the remainder of the 20 millisecond period. Again, this illustrates a longer time that the pulse is on, even longer, 2 milliseconds to 2.5 milliseconds. Okay? And this is what we call the duty cycle as well, how long the on time is versus the off time. So if I wanted to make a 50% duty cycle, I would have the on portion on for 10 milliseconds, and then the off for the other 10 milliseconds. Okay? So again, based upon that, we actually can move the robot. Now we can move it clockwise or counterclockwise depending on what code that we use. So let's take a look at what that code may look like. Let me pull up the robot design here. Now let's go into some basic servos here, and I'll zoom in here in just a moment once they get through some of the help options here. Okay, so now we're talking about the servos. Let me zoom in a little bit here so we can see. I'm going to go to a page that looks similar. You can look through some of these examples if you want to. I'm going to try to get to the servo motor. Here we go. Now, this is still pulsing the LED. Let me keep going here. Yes, here we go. Here's the servos. Okay. Now, the manual is going to tell you how to plug your servos in actually into the board versus the connector that you originally had it in. And if we look back at the webcam here, I've actually built my Boe-Bot that Mark gave me in the fashion that is mentioned in the book. Okay, so I have a lot of these wires all right here for all my servos. Okay, so really just go by the book and connect those appropriately, and you can pause the video and go ahead and construct that portion here on your robot that's highlighted inside page 47 of your manual. Okay. Alright, so hopefully you got everything wired up now. So let's go ahead and look at how some more things are wired up. This gives you an example of how the LED circuit may be built. We're not going to be building that just yet. But we are going to talk about the servo motors. Okay, and what particular code we're going to use to program the servo motors. Okay, any kind of programming language is going to have what's called keywords. So if we go back to the example, this frequency out again that was found under open from BS2 directory, I opened up this frequency, you're going to see special colors for special words. Okay? So, like the word debug, the word frequency out are in blue. That means they are a special word syntax for this particular programming language. Okay? This is the frequency out that we're going to be using for the particular servo motors. Alright, so let's go back and look at what this is trying to tell us. So since these servos are continuous servos, they might be off center. So if you plug your robot in and power it on and notice that one of the servo wheels are moving constantly, then it's probably out of the center for the robot. Okay, this shows you how to recenter the robot. You essentially use the screwdriver that come with the kit to recenter it. Okay. Now again, I mentioned before that the robot has a 3-position switch, 0, 1, 2. And the 2-position switch, when it's in the second position here, that means it turns the servo motors on. When it's just in position 1, all the servos are turned off, so the robot won't walk away with you, move away. Okay. So let's take a look at how they calculate the pulse out code. So this is going to be a pulse for our particular servo motors. So again, a pulse is talking here is the length of time that it's on versus off. Okay, so this shows an example of a 1.5 millisecond pulse sent to the servo. Okay, so it sends a 1.5 millisecond pulse and then stays off the remainder of the 20-second time period. Okay, so now we're going to figure out the pulse out command. So the pulse out command is calculated by the duration of the pulse divided by the entire period. Okay. So 2 microseconds equals 0.000002 seconds. Okay. To do that calculation, you get 750. That's the argument we're going to send out to the pulse out command. Okay. And then this shows you the syntax. Pulse out 12750. Now, if you've not already guessed, this 12 here, this argument here, indicates what pin the servo is supposed to be attached to. Okay. If you recall, we connected the servo to pin 12, okay? And so if I wanted to test pin 13, P13, again, just to remind you here, pull up my webcam here again. So P13 was here, okay? And then P12. Again, P12 and 13 are mentioned over here, and they're connected to those 2 servos, so we can test that code pretty easily. So I'm going to go ahead and copy and paste that into the Boe-Bot IDE, hitting Control C and then right clicking and hitting paste. Okay. Typically you want to put that after you've established the P-Basic and stamp. Again, just a programming preference. Okay. Also, a good programming practice is to put comments after your code, because most people's not going to know what pulse out means 12750. So a relevant comment might be sends a pulse signal of 750 value to pin number P12 on the Boe-Bot. Alright, I don't have to be very specific here, but it is kind of nice. Okay? Now, if I want to go ahead and run my code, that's fine. I have to check the code first to make sure there's no errors. Okay? So up here at the very top, you're going to see an option to check your code with the check mark here. Okay? Notice that the tokenize was successful. The green bar comes up at the bottom. There was no errors in my code. Now, if I want to download my code to the board, first I have to check what board that I have with my ID check here. See, nothing is on now. I've got the robot plugged in, but the position of this 3-position switch is in position 0. So if I go to position 1 to turn the robot on, again, just look at my webcam here, I've now turned the switch on to position 1, and the LED light is now on. Again, this green light on the adapter is still on as well. Now when I hit the refresh button, I should find my P-Basic 2, Basic Stamp 2, connected. Okay, go ahead and hit close. And then to download the code and run the code to the board, you hit the play button, which is here, the play button. So it'll go through the process of downloading the code, and then it'll run the code for you. Now if you want to check what the servos are going to do, again you have to move this switch to position 2. Okay. Seems that both of my left servo, which is pin 12, is completely calibrated correctly because it didn't move. However, if I wanted the robot to move, let's go ahead and change this 750 argument over here to a different value. So let's say I wanted to have the robot to actually move. Let's see what they mentioned to us here. This is again the centering code that we have. Now we can go to actually moving the robot to something. Okay, so again 750 was calculated from this formula here, which was the amount of time to be on versus the amount of time to be off. Okay, we also figured out inside of our code here that the speed can be controlled by the input. Okay, if you've got 1, 1.1, 1.2, depending on what you're working with here. Again, everything depends on this 20 millisecond cycle. So let's try a 1 millisecond pulse. Okay, so let's see what that particular pulse would look like. Okay, if we do the calculation for that, let me go ahead and pull up the calculator here so we can take a look at that. So the calculation that it proposed to us in the manual, let me get back to it here, was the pulse duration of 0.0015 seconds, or 1.5 milliseconds. Okay, that was the code to make the robot just sit still. Okay, what I wanted to do was to make the robot move. So I'm going to say, let's make it be 2 milliseconds. Okay, so 2 milliseconds. Let's go ahead and plug that into our formula. So it would be 2 milliseconds. So it would be 0.0020. Okay, and this bottom pulse always stays the same. It's always 20 milliseconds. Okay, always 20 milliseconds. All right. So let's go ahead and plug that into our calculator here and clear it out. So if I have 0.0020 and I divide that by 0 point and then 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, and then a 2. Okay. Now let's go ahead and see what we get. We get to be 1,000. Okay. That's the argument when we want to put into our programming code. So let's go ahead and go back to our program. And let's change this 750 to 1,000 on pin number 12. Okay. So again, you want to check your code with the check mark here. Everything was green, it was good to go. And then you want to hit play to run your code. Okay. Now it seems like everything is okay. Now let's see if we can get any motion on our robot so far. Looks like the 1000 still kept the robot in a still position. That's the pulse out to the robot. Alrighty. Again, that's how you're going to calculate the values for your pulse out. Okay. It goes through a couple more examples here of the different variables that you can use. Again, I'm not going to go through this entire manual, but I will highlight some of the important code that we have here. Okay, this is the pulse width controls the speed and the direction. So a 1.3 millisecond pulse train turns the servo full speed clockwise. So let's go ahead and calculate what that would be. Okay, a 1.3 millisecond pulse. They've actually already calculated it for us here. It ends up being 650, but you can do that same calculation I did a moment ago and get 650. So let's go ahead and just copy and paste this code here. Again, I'm going to copy the code and put that into my editor. Okay, and paste. Alright, good deal. So I'm going to check my code here, see if it runs. There should be no errors happen. Then I go ahead and download the code to the board. Now, this debug terminal will come up because the debug window was initiated. Now if I go back to my webcam, you're going to notice that my robot wheel, you probably can hear it already, but we'll get the video working in just a moment. The wheel is moving in a clockwise position. Okay, get my thing here. There we go. So it's going in a clockwise position. So let me go ahead and stop it for just a moment, just so you can get focused. So the wheel's going to be moving in a clockwise position. Okay. Now I will try to put something on the wheel just so we can keep track of what direction the wheel is moving. I'll put this little stay tie onto this. Okay. Now hopefully you can see the stay tie and watch the stay tie move. Okay. So I'll try to do this in segments. So there's that. See if we can get it in focus a little better here. Maybe I can get a piece of a sticky note here, may help. I guess want to have some kind of visualization of where the robot is going. There we go. Let's go ahead and turn the robot back on. Now, hopefully you can see it's moving in a clockwise position. Okay. Now let's go ahead and go back to our program here and change this code to reflect a full counterclockwise position. Okay, so it turns out that arguments less than 750 will cause the servo to rotate clockwise. Okay, so now what do you think if there's anything above 750? So this is going to be counterclockwise. If I want to go counterclockwise, let's go from 650 to 850. Okay, let's go ahead and change this to 850. Now I'm going to go ahead and put my sticker back onto the wheel again, just to kind of illustrate where this is going. So before, just to slow it down for you, before we had the wheel moving in this direction here, okay, which was our clockwise position. Now if I want to move in reverse, which is a counterclockwise position, this value here is at 850. So I'm going to try to do this in both times here. I'm going to try to keep this on top so we can see this happening in real time. So if I hit play on the robot, it should instantly download and then start moving the wheel. There we go. Okay. So it's a little hard to see on the webcam, but it is moving in a general direction around this way here. Okay. I'm going to go ahead and move my switch to position 1 and stop the robot. And really that's it. That's all there is to get the robot actually moving. Okay. Now let's say I wanted to move both of the wheels. As you can guess, I would have to choose pin number 12, because again, pin number 12 and 13 are what is connected to my servo pins right over here. Okay. So that's what's connected over to here. That's pin 12 and pin 13. So let's go ahead and copy this row, Control C, and paste it into here. And let's change this one to pin number 12. Again, you want to check your code. Everything should be fine. And then let's go ahead and hit play to run the code. Now, an interesting thing happens that we're going to try to observe. Now, notice how the direction that this particular wheel is moving, again, is moving from this direction here. Forgive the poor quality. Now if I flip the robot over, put the tape back on and move it again, notice that it's moving in the same direction. However, if this wheel is moving in this direction and this wheel is moving in this direction, you actually end up turning the robot. Okay? So the robot would make a motion similar to a left or right hand turn depending on how you've positioned your robot. Okay, so this is how I have mine positioned. Again, these are going to be different values depending on which way the robot is situated. So what I have here is the robot when one's going in this direction and the other one's moving in the opposite direction. So one is going in this direction and the other one is going in that direction. So I would be moving the wheel in a turning motion. Okay? So what you can do real fast, just to kind of test yourself with this code and your robot, see what values here would make the robot go forward and backwards. Okay? Again, you can refer back to the manual that tells a full speed counterclockwise is 850 and a full clockwise is 650. Okay? So you can try, 750 is the very center position. Okay? Or 0 position if you want to stop the motor. Okay? So a good activity for you to do to pause the video right now is to go ahead and take your robot and program your robot to move forward or move backwards. Again, you can make the robot stop by putting 750 as the argument. So go ahead and pause the video and try that for a few minutes. Okay, welcome back. Hopefully you've got some experience of working with the Boe-Bot now. We can actually program something into the robot. We've figured out how to download the IDE and get it up and running. We know how to check our code, which is here, and to run our code, which is the play button. Okay? So hopefully by now all those aspects are working. If it's not, you can contact Mark or me if you wish, and we'll see if we can get you going. Now, one of the team's project is obstacle avoidance. Okay? So let's talk about how we're going to do obstacle avoidance. Okay? So one of the methods that we have available to us for obstacle avoidance is the IR sensor. Okay? The IR sensor, I'll pull out my particular robot here and show everyone. Let me get my webcam back up. This is the one that I built, that Mark let me graciously borrow. And I went ahead and built the IR sensor pair according to the manual. Okay, so you're going to have a emitter right here and a receiver right here. So I'll highlight that with the mouse. So again, there's your emitter and your receiver. Okay. Now let's talk a little bit about how we're going to use these particular sensors. Okay. The sensor works in this fashion. You send out a beam of light, infrared light, and it comes back. If nothing comes back, that means there's no obstacle in the way. If something does come back, that means an obstacle was detected. Now we can also detect the brightness of something with an IR pair similar to this. You can see that you reflect more light off of a white substance object versus a black object. It absorbs the light. Okay? Now we are going to be simulating that with actually the set of IR sensors that come with our robot. Let me go ahead and flip my robot over to kind of show you what this will look like. Now here are the IR sensors that we have on our robot, called QTI sensors. Okay, let's look at the data sheet for them for just a moment. And again, if I'm going too quickly in this video, feel free to pause it and look up some of these resources online that I'm using. I'm going to try to post all the links that I'm using today in the presentation in the description box below. So here's our data sheet for the Parallax sensor, the QTI sensor. Okay. And let's look at some of the values that we have here. This is the working schematic of the QTI sensor. You have an emitter and a detector. And this shows you how the line sensor test can actually be used. You can get the line sensor power and line sensor input. Okay, so here's some of the basic code that we can use. And feel free to copy and paste this code into your basic software, basic STAMP software here, and test it out. Okay, but again, the purpose of that line following capability is so these robots can operate. So one of the ways these robots operate is typically if there's not a black line in the middle of the hallway, there's usually embedded into the concrete some kind of methodology for the robots to be exactly in the center of this particular aisle that is in right now. So we're going to mimic that with some black tape and some for the sensors mounted on the bottom of our robot. That's how we're going to simulate that. Okay, just to show you again, there is the 4-hour sensors. Again, refer to the manual to construct these. Okay, alrighty. Now mine also has the grabber kit. If you notice, it's kind of nice. One of the teams are going to have to work with that grabber kit. It's a little bit hard to construct, so I will leave the robot with marks. You can kind of look at mine as an example, but it's not too awful bad. Now, another thing that this robot is going to have to do is to be able to actually traverse the pseudo warehouse that we're going to try to mimic. Okay, so we went over how our sensors work, and we went over how basic servo motors work. Okay, so again, the servo will be key for the team that's working with the grabber bot and the obstacle avoidance team. Okay, because they're both going to have to make the robot move. But you can work on this independently of each other. Okay, so let's talk about how we're going to wire up the Boe-Bot. Again, if you look at my particular robot here, it has a lot of stuff here on the breadboard. Now, the images inside the user manual work really, really well. Okay, however, I did want to go over the basics of a breadboard. So let's go to our more, for lack of a better pun, basic example here. This is an empty breadboard. So let's look how a breadboard works. So you're going to have, don't worry about the power rails here. We basically just have this portion here in the middle. Okay, this is how they're connected. They have rows that connect 5 at a time. Okay, so these 5 rows here correlate to the rows here on my particular robot here. Let me shrink the image down here a little bit so we can see, and always keep this on top. So again, here's our breadboard here, and here's the breadboard that correlates to this. So all these connections here are connected together. Okay, they make one single connection. They are not connected across each other. Okay, and again, there's plenty of stuff online to kind of help you with this, but I just kind of wanted to give you the basics of how this breadboard works. So go by the book. The manual is a great resource. There's also some resources online that can show you some of the basics of a breadboard. Okay. Alright, so we went over the breadboard. We went over the basics of the IR sensors, both the line following sensors and the object detection sensors. And we went a little bit over the servo motors. Okay. Now, by no means can I go over everything in one lecture. However, I did want to get everyone started with the Boe-Bots. Okay, so do pay attention to what these different colors are. Again, anything in blue is a syntax command. Anything in green is a comment. Okay, and then these are the arguments to that comment. And the servo motors are connected to pin 12 and pin 13. We also learned that to make the robot go counterclockwise, we put an 850 to the code, and to run clockwise, we put 650. So those two numbers are very important to you. And 750 was the null position. Okay, if you go back up here and look in the manual for the null position here of the particular servo motor, let's go back up here, and then that was 750. That nulls out essentially moving 0, no position. So let's write that down in our comment here. Let's make a comment right here and say servo motor, next line, 750 equals no movement. Then we have 850, which equaled, I have to double check myself here and see what 850 was. Alright, so 850 was full counterclockwise. So this is counterclockwise. And 650, let me line this up a little better, was clockwise. Now, one of the challenges I would like for you to do by next time I teach, and I will make the next lecture, I'm going to be presenting on the Boe-Bots again on the 26th. So I will see you on the 26th, September 26, 2016. So what I'd like for every team to have done is first mount all the sensors for your robot. Make sure the line following sensors are mounted if you're that team. Make sure the obstacle avoidance sensors are mounted if you're that team, and the grabber if you're working with that portion. Now, central to all of this is moving the servos, being able to move forward, turn left, turn right. Okay, you can pivot or turn. Work with the servos quite a bit on this code we have here, just to see what is going on. So, what I'd like for each team to do is to be able to go in a square. Okay, so you should be able to move the robot forward, then make a right-hand turn, another right-hand turn, and another right-hand turn. Let's see if we can get it moving in a square. Okay, there should be some examples in the book of things similar to this, and at minimum, each team should be able to make the robot go forward, stop for a while, and then go backwards. Okay, that code's already out there we can look at. You just got to look up the code for that. So, again, just kind of went over some of the basics today of the Boe-Bot, how the servo worked, how the breadboard worked, why we're doing this project with the Amazon Fulfillment Service robots, where to find some of the resources as far as the IDE to download everything. So we went over that as well. And again, this is the grabber PDF. I will post this. This was kind of hard to find online, so it gives you a little more detailed information. I like the color pictures. One advice I can give is to go slow with this. You also will not have enough of this padding material. I cut it out to their specifications and did not have enough. So again, just kind of go slowly and double check everything. You will have my robot to go by. Okay? So you can use that as an example. Alright, so if you have any questions about this lecture, feel free to email me. And again, there will be a quiz for the next class based upon items that I've covered in this lecture. It may be items such as how to program, how they calculate this value here if I gave you a diagram. Okay, how we got 650, 850, and 750, that may be a problem. I also may ask you what pin the servos are mounted to. Again, the servos are mounted to pin 12 and pin 13. Again, it doesn't matter which one you connect it to. It left could be 12 and right could be 13 or vice versa. I also might quiz you on what position the switch has to be on for the servos to be on. Position 2 is the answer to that. And 1 is just an on position, and 0 is the off position. Okay? So that's another question I may ask in a quiz. And I may ask some of the basics of how this IR sensor works. Okay, as far as white reflects the light and black absorbs the light. Okay, so just some basic stuff just to make sure you watch this video and hopefully been paying attention. I think it's going to be an interesting semester with these Boe-Bots, so hopefully you have some fun programming these guys. I know I've had some fun working with them. And again, if you have any questions, just talk to Mark or me. I'm available via email, and I will be on campus again on the 26th to check your progress thus far with the robots. Okay? Alrighty, so again, if you have any questions, just contact me. And one last assignment that I would like to assign by the 26th here. Since the servo motors are so vital to each team's progress and each robot doing the required task, I will ask if each team will send a memo to each other team. Okay, so you're going to send out 2 memos. There's 3 teams, so you should send out 2 memos apiece. Okay, and I want you to write a simple memo of what you learned about the servo, how the servo works, include some figures maybe, and how servos are vital to your portion of the entire robot. Okay, so again, the requirement is there's going to be a quiz next class. I want the robots to be built with all the sensors on the robot. As you saw my example, you should see by next class. And I would like for everyone to program a little bit on the Boe-Bot. Okay, so those 3 things. So memo by the 26th. There should be a quiz next class on the 19th that I'm going to give to Mark to administer. and you should have the robot built and doing some coding. And again, if you have any questions, just email me, and thank you for your attention today, and have a good afternoon.